Okay, let's go ahead and add and subtract algebraic fractions. The first few that I'm going to share with you already have common denominators. So we'll look at doing the addition and simplifying, because not only do you have to add and subtract the numerators once you get a common denominator, but you have to go back to the very early parts of the study of algebraic fractions, and you have to simplify as well. So number 9 has a common denominator of 2y. So you're allowed to add the 3 and the 5 and put it over that common denominator. So the 3 and the 5 add to be 8 over 2y. So this is what I mean. 8, if you want to see it like this, 8 is 2 times 4, 2y is 2 times y, and you have to remove a common factor of 2 out of the 8 and the 2 and write this and reduce this as 4 over y. So please, you must remember to reduce. So I actually wish I didn't have so many buttons here. The next one has common denominators, and I'm going to highlight this x and this x because they have to be combined. Because the denominators are alike, I'm adding the numerators. So 1x plus 1x is 2x. And then this minus 3y and this plus 5y add to be a positive 2y, and now that's over the common denominator of x plus y. But oh, wait a minute, I'm done? But when you're done adding and subtracting fractions, if you can factor anything, like take the 2 out of this, you should. And then the downstairs is a binomial, x plus y as well. If you can remove a common factor, then you should. It means that no matter what x and y are in this problem, you'll always get an answer of 2. It's so interesting, truthfully. In this one, I'm just going to move the negative sign up with the 5. I'm going to rewrite the problem so you can see it. I'm going to write it as 2 over a plus a negative 5 over a. You know, I could have said to you, let's multiply the top by a negative 1, and let's multiply the bottom by a negative 1. You're multiplying the same thing, top and bottom, making the denominator a positive a. You're now ready to add these because the denominators are alike, and 2 and a negative 5 add to be a negative 3 over a. All done. So be careful with this one. In order to make this become the same as this denominator, x minus 3, I need to distribute a negative 1 times this. So the negative 1 times x will make that, I'm going to take this way over here. A negative 1 times that x will make it a positive x, and a negative 1 times 3 will make that a minus 3. But if I multiply the bottom by a negative 1, I got to multiply this top by a negative 1. So the 2x will become a minus 2x, and the minus 5 will become a plus 5. And now I'll put the first fraction here. I'll just recopy the 3x plus 1 over the x minus 3, and I'm ready. But oh, lo and behold, I need to subtract these two. So remember, since they do have a common denominator, but when you subtract this numerator, you've got to make this become a positive 2x, and the 5 becomes a negative 5 over that x minus 3. So you're adding the opposites. And now I am ready to take the 3x and the 2x and get 5x, and the 1 minus 5 and get a minus 4 over the common denominator of x minus 3. Nothing can be done here because these cannot be factored, so they are binomials. There is nothing to reduce. Okay, if a common denominator does not exist, you use the rules that we did a bit ago. You factor the denominators if necessary and find the least common denominator. Here you go. You write an equivalent fraction so that it will have the least common denominator by multiplying by the number 1. So let's go ahead and do that. So we already know that 16 and 24, let's see, multiples of 16 are 32, 48. Multiples of 24 are 24, 48. So the least common denominator between a 16 and a 24 is the number 48. So I'm going to very clearly specify. So the 3x over 16 needs to be multiplied by a 3 over 3 because the 48's in the third spot. So 16 times 1, 2, 3 will give you 48. So this will become, I'm going to write this. This is called writing the equivalent fraction. That's called 9x over 48. The 7x squared over 24 needs to be multiplied by 2 over 2. Remember, you're multiplying by the number 1. This is my kind of fun little play with this. You're multiplying by the number 1 because you're multiplying by the same thing over the same thing. So upstairs, 7x squared times 2 is 14x squared. And downstairs, 24 times 2 is 48. I'm ready to add them because they have a common denominator. So I'm going to put the 14x squared first and then the 9x over the common denominator of 48. And while this has a common factor of x, I could factor out of it in hopes of simplifying. There are no x's downstairs to simplify with, so I'm not going to bother. And the 14 and the 9 don't have any common factors. Okay, the LCD for this next one. 3 divides into 12. So 12 is the numerical value. The least common denominator needs the greatest number of x's in any one of these denominators, and that's an x to the second power. So this 5 over the 3x squared needs to become a 12x squared. So you say to yourself, what do you multiply 3x squared by to get a 12x squared? You multiply it by a 4. So upstairs, you're going to have 4 times 5 is 20 over 12x squared. All right, the second fraction was 7 over 12x. So it's got the 12, it's got ax and x, it needs another. So if you multiply this x by x, you'll get x to the second power. So you got to multiply the 7 by x as well, and you'll have 7x over downstairs 12x squared. You want to add these, and so the numerators are not like terms, so you just got to put the 7x plus the 20 side by side all over the common denominator of 12x squared, and 7x plus 20 cannot be factored. So there's nothing I can reduce it with downstairs. So I'm going to leave it as is. Let's keep going with several more monomials. So let's go through 3 more problems or so. And we've worked at LCDs, so I'm going to kind of work through this quickly. You may want to pause and do these on your own. So a needs to be to the third power for this one because that's the biggest exponent, and b needs to be to the fifth power. So you see this denominator? It's got a b to the fifth, it's got an a to the first, it needs to become an a to the third, so doesn't it need an a squared? Top and bottom. So that'll be an 8a squared over a cubed b to the fifth. This one's got a cubed, but it doesn't have b to the fifth, so it needs a b to the third because you add these exponents. So top and bottom gets multiplied by b to the third, so the numerator becomes 5b cubed over the a cubed b to the fifth. And now I put these together. It's an addition problem. I'd probably put, oh, I don't know, it doesn't really matter. Sometimes a goes first alphabetically. But b is a degree of 3, so it could go first as well. A to the third, b to the fifth is a common denominator. This can't be factored. I cannot reduce it. Let's see. I'm just going to tell you the answer to this one. The least common denominator, though, I believe is a 72 and an x. So I believe this will have to be multiplied by 3, so that'll become a 21. And then this one probably has to be multiplied by 36, probably by a 4. And so this numerator, gosh, I guess I'm going to go ahead and finish it, I think is 52 over the 72x. The next one is 21 over the 72x. And the numerators add to be 73 over the 72x. And I think I'm good to go. How about if you go ahead and finish this last one on your own, knowing that the least common denominator is a 6, because between a 2, a 3, and a 6, that's the least common denominator. You need a p and a q in your denominator, and I find that you're going to have 1 plus 14q minus 27q all over 6pq for a final answer. When we come back, we're going to look at some problems where you don't have monomials in the denominators, but you have binomials and trinomials. They'll get a little bit harder.